And here we are. Hey, everyone. Welcome to another episode of CDK Live. This is a really exciting episode. As you can see, it's not just me here today. We have some really awesome members of the AWS team that have built a really cool project that we're going to talk about in just a moment. But if you are here and you want to say hello, we always like hellos in chat. Gary, hello. Good to see you here. So in this show, we're actually going to talk about the data solutions framework. I hope I said that right. Data solutions framework. Yes. And before we get into it, I just want to say that, in my experience, I've been building in AWS for, I think, over a decade now. I've been doing just in the industry for over 15 years actually. And what I've seen, one of the most challenging aspects of when you're working with data teams, and data teams are trying to build and get what they need in a relatively reasonable pace, the governance, the automation, all of these things are very challenging. And what I'm really excited to talk about with all of the three folks here today is how we can simplify that process, onboard these kind of data patterns, these workloads that are very common at a much faster rate and in a more reproducible way. So before we get to introductions, we do have some folks. Let's say hello to Juan. Juan, hello. And wow. And Andrew from New Zealand. Okay. I don't know what time it is there. Is it morning there? I don't know. But also I know the other folks here with me right now are across the globe too. It's not just here in sunny Southern California right now. I got the sun shining. So hopefully the sun's shining wherever everyone else is. So let's get started with some introductions, and then we're going to dive right into the really great content. Janan, why don't we start with you? Say hello and all that good stuff.
Hey, Adam. Hey, guys. Really glad to be here. My name is Janan. I'm a solutions architect at AWS. Well, actually, good evening from my end because I'm joining from Germany, from Berlin.
Nice. Hey, Janan. And by the way, Janan had a really nice shirt on, and he saw how casual I was. And he's like, you know what? I got to go casual.
It's just going to remain black today. Yeah. Black shirts, all of us. Yeah.
We decided to go with the black shirts. Lotfi, why don't you say hello?
Hi. So this is Lotfi. Good evening. Here in Ireland, Dublin. I'm a principal solutions architect. I work mainly with our public sector customers, and I decided to wear a Space Invader t-shirt once Zenan changed his shirt. So, and keeping it also black.
Nice. And Vincent?
Yeah, this is a nice t-shirt. I just have a reinvent. Hi, everybody. This is Vincent from France. I'm a specialist solution architect in analytics, and I work with all kinds of customers across CME, across the world on solving analytics problem.
Amazing. So clearly we have the right folks here who are going to tell us how we can solve our big data issues here with the data solutions framework. So Andrew said it was 8 a.m. in New Zealand, and we have 6 a.m. So, hey, Josh, how you doing? Okay, so you can see we're global here. We're not locked down to one particular geo. So, Janan, why don't you start us off here, and let's kind of take it from the top. Let's start with just introducing the data solutions framework. What is it? How did we get here? And all the good stuff that it provides.
Absolutely. Let's do that. Actually, I have a few slides. I promise it will be just a few slides. We'll show you code, we'll show you demos. But just to get started here, to show some concepts behind the project. So let's get into it, actually. So today, I'm going to start talking about why we actually built data solutions framework in the first place. So what are some of the challenges that inspired the creation of the framework? We'll then obviously introduce the framework itself, talk a little bit more about it. And then Lotfi and Vincent will show us a demo. So we'll see some code later today. So let's start. So all of us work with customers all over the globe. And a big part of our job is really to listen to our customers. What are the challenges they have? What kind of problems do they try to solve on a daily basis? And so when it comes to data, we recognize that to build a data platform today, is pretty complex. You require a lot of different specialized skills. So that ranges from skills in infrastructure. So obviously you need to build infrastructure in the cloud, but also from security, how all of these components can interact with each other in a secure way, all the way to networking and then distributed systems, etc. So as you can imagine, this is a really kind of wide scope to have, especially on the individual level. We also hear from our customers that they spend a lot of time on integration and infrastructure. By integration, I mean there are a lot of different services out there. Doesn't matter if it's really managed services or we're talking about the open source tools. There are so many tools out there that you can use, and then you spend a lot of time actually on the integration. And what we hear mostly is that people want to focus on the use case. They want to solve a business use case. They don't want to spend too much time thinking about infrastructure, don't want to spend too much time thinking about how to really integrate all of these different components, especially in a secure way. They want to just build an actual solution, solve a problem, solve a challenge, play with their data at the end of the day. This is why we decided to build a data solutions framework. So let's start with what it is actually. So data solutions framework, or DSF for short, it's an open source framework that really simplifies implementation of data solutions. And I think by the end of this session, you will see exactly how it does that. So with data solutions framework, what you can do with it. So you can compose different data solutions. You can do so by combining different data patterns. So these data patterns are actually packaged as building blocks. And all of those building blocks come with smart defaults and also built-in AWS best practices. So for example, if you decide to use DSF to build a solution, you can already know that all of these components are built based on the AWS best practices. For example, least privilege in IAM. Also, DSF is really easy to customize. So it's open source, but what's really important, it's not a black box. So you can go ahead, you can change what's inside, and it's not exclusive to be used, as a single tool of choice. So, for example, if you leverage CDK to build your cloud solutions, you can combine DSF with any other CDK application, and you can just decide to use a single component out of it that you need. So it's pretty easy to customize as well. DSF is packaged as AWS CDK library. So that means that you can install it as a part of your CDK application, and you can do so in both TypeScript and Python. So if you are a TypeScript user, you would do that through the npm. And if you use Python, you would do that through PyPy. So just installing that as an additional library to your CDK application and just consuming whatever you need from the DSF. So as I mentioned already, you can really use DSF to accelerate building solutions on AWS. We primarily built DSF for data platform engineering teams. So that means for teams that actually provide data services to other teams in the organization, to business teams. But of course, anybody can use DSF from data engineer, data scientist, or data platform engineer. So I'll try to break it down here just to maybe get a better understanding how we position DSF. So with DSF, as I mentioned, you already get common patterns that we can see in analytics. So for example, a data lake, and you work with this level of abstraction. So for example, in data lake, you don't deal with an S3 bucket through the data solutions framework. You actually deal with the data lake itself as an abstraction. So there are different tools and helpers inside of the framework, and all of those you actually can interact with through the API. And then you, as data engineer or data platform engineer, you focus on your actual business use case. So you create your business logic, you leverage your data, you simply build your solution. You don't think about all the underlying concepts that you would otherwise need to think of, for example, networking between different components or security, for example. So let's go a little bit deeper into those building blocks that I mentioned already a couple of times. So building blocks are actually abstractions on top of AWS services, and these abstractions are based on AWS CDK level 3 constructs. So for those of you who are maybe not familiar, even though this is a CDK channel, we have 3 different layers of abstraction in CDK. Level 1 would be direct mapping with the actual service. Level 2 would be already having some best practice in place. You don't have to configure everything. So for example, an S3 bucket. So you can just use that S3 bucket. But then level 3 would be opinionated implementations of common technical patterns. So you can imagine that if you use frequently SQS and Lambda function that actually consume that queue, you can create an actual construct that presents this technical pattern and then reuse that pattern across your different applications. So
yeah, Jenan, we had a question from the chat.
Mm-hmm.
So I think we already answered, yes, it's built on top of CDK. It's layer 3. The beauty of the thing is we write once in TypeScript, and we are using GSII to convert all this code into Python. So that means you
Correct.
can also use Python, and code check and everything is perfectly handled with GSII. So you can use the library as you want, and you can mix with your CDK application. We do not enforce anything in DSF. It's just additional library that can help you build more quickly.
Exactly. So as I mentioned, you really can install this as a part of your application and then just pick and choose components that you actually need. So for example, here on the screen, I'm showing an example of a very simple application. So for example, line number 4, I'm just creating a data lake here. So you could imagine that when you build your solution, maybe you only need a data lake and just to store some data, to upload some data. So you don't need to use anything else from the DSF in that case. So you can really just choose what you need. So here I just want to guide you through a very simple use case and to show a little bit more about different building blocks that we have. So for example, in this case, I want to build an application, CDK application that will have data lake storage. And then I'll store some data in my data lake storage, but then I want to process this data. And I wrote a simple Spark application for it. So I would need to package this Spark application to upload it somewhere on AWS. But then I also need to schedule a job to run this Spark application on a runtime that I created previously. So I can do all of this in these 20-ish lines of code. So if you exclude parameters, that would be actually 4 lines of code. So you can see here each building block. So in this case, I'm showing data lake storage. You can customize through parameters, obviously. There are different methods for each construct, or you can really deeply customize each of these constructs through a CDK escape hatches as well. So line number 4, I'm creating data lake storage. You can see that this building block, for example, comes with the medallion architecture. So that means 3 different S3 buckets to store our data into bronze, silver, and gold tier. We also have enforced encryption and different lifecycle policies. Next, line number 6, I will be using Spark Runtime Serverless building block to actually create my Spark application on the EMR serverless. So this will create my runtime. It will create all the different roles and policies that I need. So you don't need to think about that. Next, I'll take my business logic. So in this case, PySpark, and I'll use our building block PySpark application package to actually package this application so I can later run it on the runtime that I created. And then finally, line number 17, I can use my Spark EMR serverless job, that is another building block that we provide in DSF, to actually now schedule a job on the runtime. So using the application that I wrote and uploaded previously. So this just gives you a glimpse of different building blocks that we have that we'll go deeper in later in the demo, and how you can construct very quickly a pretty common solution that you can see these days.
And Jeanette, I just wanted to add, like, the fact that you're able to take your application code and couple it with all of these, all of your other constructs here that you're building, it's kind of that next iteration of infrastructure as code, and kind of where we see where things are going, where we're coupling these things. Where no longer do we have to have separate, repositories and keep things separated. We can keep our infrastructure code tightly coupled with our application code that manages all of this, and it's all in one place.
Exactly, and you can also do continuous integration with it. So later you'll see Vincent will show CI/CD pipeline for this particular example. So you can have a continuous deployment of your application as well.
Yeah, we really leverage the power of CDK for this. Okay, it has some unique features like being able to package using Docker. So that means you can bring your code, your dependencies, package everything, and use your infrastructure code to just make it available for running your application. We will see that in the demo, but yeah, that's very powerful. I'm a big advocate actually for this way of operating and developing, having infra code, business code in the same repo, and even the CI/CD code. That means you fully own your code, and you can mutate it as you want.
Exactly. So you can think about in the organization as well that the platform team actually becomes the team that provides these blueprints for other teams to use. But then other teams, for them, now they work with on a different level of abstraction. So they can actually manage both infra and the application code, because they don't need to go very deep on the infrastructure level. That's being done by a platform team. In this case as well, what we have done with the DSF, right? So really enabling data engineers to operate on the right level of abstraction, but still owning the business logic and infra that they use.
Yeah, and nothing prevents an AWS customer to take this library and build its own library on top of that. Like that's a very frequent requirement we have from our customers. How can I customize resource, or how can I adapt these packages to my governance rules or security rules because I have a specific way of working? You can still do that. We expose all the resources, all the CDK resources that we create. We expose everything, so you can still mutate what you want. You can still adapt. For example, in the data lake storage, we have a default policy for transitioning from standard class to infrequent access and Glacier to save on cost. But you can first change the configuration because it's part of the API of a construct. And even for things that are not part of the API, you still have access to the individual buckets that we create. So you can change any parameter at the end. You could just instantiate the construct and then access the resources within it to just modify whatever you want.
That's a really good point. And I think this is when folks are working with the CDK and you go higher up in the level of constructs, when you get to an L3, oftentimes that can be, with some of the older L3 constructs, that can be a pain point, that you don't have access to these resources that are created. So the fact that y'all thought of that and you're making these resources available is a really, really good idea.
We have the best of both worlds in that case.
It's awesome.
It's really important to make it highly customizable. That's one of the tenets that we have for the project, indeed. So moving forward from this quick deep dive into building blocks, so let's cover what we have in the framework so far. We cover different layers in the overall data platform idea. So we have building blocks to support storage, but also processing, governance, consumption, but also different utility functions that you can use just to simplify building. So for example, there's a utility to load the data into your data lake. So I already mentioned that from the storage, we do have a data lake storage that is based on the medallion architecture, but we also do have on the governance layer, we have a Glue data lake catalog that comes with pre-configured crawlers. We have a Tina work group, but also MSK, so managed Kafka with topics and permissions. There's also Redshift serverless, EMR serverless, EMR on EKS, PySpark application package already shown earlier, Spark CI/CD pipeline we will see later in the demo, and also OpenSearch cluster. We are continuously building new building blocks. I will talk a little bit more about the roadmap later.
Yeah, what I can add just on the previous slide, a simple thing that really brings some value for our customers is when you have a service, we have different kind of patterns, okay? But even a simple one like MSK or Redshift or OpenSearch, they are already very useful for our customers because they give access to the data plane API, okay? So that's pretty cool because, for example, for Kafka, you can already provision an MSK cluster with CDK and the L2 construct. But what we provide is also a way to create the topics and delete the topics and also do grants through IAM permissions on the topics. So that's pretty cool because you have everything available in CDK. You can already bootstrap your code and you can even adopt the GitOps approach if you want. And yeah, manage your entire infrastructure with code. That's feasible. So we provide this for MSK. We also provide this for Redshift serverless. You have the data API. You can run some SQL queries as part of your CDK code to, for example, load data or create tables, whatever you need. And same thing for OpenSearch. That's something that is very popular. You want to be able to access the REST API to create index templates, or you want to load dashboard for your open source dashboard. You can manage through CI/CD using this data plane API. So that's pretty powerful. Just as simple as a custom resource interacting with clusters and doing the operations. But we manage everything for you. We scope down permissions, we create the custom resource, ensure that it's properly configured, etc.
That's really huge. Just to think about that for a moment, in the current world, without this construct library, if I want to interact with a Kafka cluster or my Redshift cluster, I have to build this automation somewhere else, right? Like this. Yeah. And if I have a pipeline, that's going to be an extra step in the pipeline. I have to figure out the resources I need to interact with. There's a lot of logic that I have to glue together. Having the ability to couple that into your CDK code is huge. You have everything in one place. There's no more, I'm managing this here and this somewhere else. I have it all in my CDK code. I know exactly what my intentions are. It's all defined very clearly in Git, in CDK. That's a really big feature. Nicely done.
Yeah, and you benefit from the CDK lifecycle and CloudFormation behind the scene lifecycle, like create, delete, update operations. So that's really powerful in terms of control on how you operate this.
Yeah, very cool.
One last thing on this is because it's an infrastructure as code. That means if you ever make a mistake, you can always reproduce the same result, whether you deploy a cluster and then you put permissions. You don't have to figure out what are the permissions. Like we'll stick to Kafka. Maybe with Kafka you have a shell with an ACL shell that you go and like type them, and then you have a very long command just to provide someone access with what we have soon with MSK, because it's not there yet released. It's coming soon in the next 1 or 2 weeks. You can just provide me with your intention, meaning like what is your topic, what is the ACL, deny or allow, on what host and what principle, and then that's it. We go and do the job behind the scene. Of course, Kafka will be always in a VPC. That VPC doesn't allow you access to internet, and there will be a Lambda behind the scene that goes and deploys in the VPC and will be applying those rules that you want.
Yeah, we have a question from Josh about custom KMS keys. So generally, everything related to security, we have an API in the construct. That's a general tenet, I would say. So you can provide your own role, for example, or your own key to generate the construct. That's something that is feasible. If we support custom KMS key everywhere, it depends on the construct. But as long as the service supports it, you can pass your own key.
So yeah, that's one of the things. We always give you the window to pass the key. So if an S3 bucket you want to deploy, you want to provide a key to an S3 bucket, we will take that key and we will pass it on to the service through the APIs. So whenever a data plane or like a data storage is exposed and you need to pass your key, we will provide you with that ability.
And there is another question about data and ML solutions framework. Yeah, I don't want to spoil. We have a roadmap overview at the end of the presentation. So we will answer this question later.
Cool. Keeps everyone hanging on, waiting until the end. I like it.
And I think we're going to be going to demo right now. So just before that, let's maybe compare with and without data solutions framework. So usually without data solutions framework, you would have to do a lot of heavy lifting yourself when building. So even though in the previous slide we mentioned different building blocks that we offer, and it sounds simple when you say Athena Workgroup or Data Lake, but as we just discussed, there are so many pieces to what actually makes that solution, let's say, production ready. So you have to think about different roles and policies, encryption keys, interactions with different services, etc. So without data solutions framework for a solution that I've shown earlier for the PySpark application, you will usually need at least a week of implementation. And you'll probably write over 1,000 lines of code. With DSF, as you could see, it's just a couple of lines of code, and you already know it's according to AWS best practices. It has all the security best practices in place, and integration between the building blocks is by default. So I really need just a few lines of code to write my full end-to-end solution, and then I can go ahead and customize if I wish. So you really focus on your business logic versus the infrastructure. Already mentioned a couple of times about the IAM, but cannot stress that enough. I think whoever builds on AWS and you want to do it right, most of the time you will spend searching for the least privileged permissions and how different services will be able to communicate with one another. This comes out of the box for building blocks with DSF. And in general, you don't need to debug your infrastructure code because this is already being done on the DSF side. So as you'll see when you go ahead and explore data solutions framework, you'll see extensive test suites from unit tests, integration tests, but also from we rely heavily on NAG, CDK NAG. So it's really extensively tested for you, so you can go ahead and use it. And I think with this, we can go ahead and show it in practice. So demo time. Lutfi, I'll hand it over to you.
Don't forget the mute, the infamous mute.
After 2 years of COVID, or almost 2 years of COVID, and I'm still making the same mistake. So kudos to me. All right, so let's help. This is our scenario today. We have this data engineer, let's call it John Doe, and he works for Taxi Corp. And he needs to set up a pipeline that will ingest some taxi data, metering data, to aggregate and show dashboard on how much money they are making. But he's on a very tight deadline. So we will help him set up the CI/CD, set up the Spark job, as well as provision the compute capacity and its data lake. So with that, I will share my Visual Studio. So I have already set up my CDK application. Since we're on CDK Live, no need to show you how to do the CDK setup. But we'll start by the requirement.txt. So how are we going to use this? So first is just add the library cdklab.aws data solutions framework, and we are today at version 1.2.0. Once we do this, we always do like the pip3. We do the pip install. It's our requirements.txt, and we are good to go. All right. We have our stack here, or like the CDK application, and we pass our stack. Now let's start coding. So the first thing we'll need to do is create our data lake. And with that, you can see here I'm already importing the CDK library, which is DSF. So import, I will just do DSF. And we have different modules, so with the intention of what we want to do. So consumption will have OpenSearch, it will have Redshift, we have governance for lake formation, as well as Glue data catalog. Lake formation is coming, but I'm spawning the roadmap. Sorry for this, guys. We have processing as well as storage and utils. So let's go with storage to deploy our data lake. So you can see here we have access log. So this is for setting a central bucket for centralizing the access log for your S3 bucket, but we are interested in our data lake storage. So we'll go for it and we'll create it. We are getting IntelliSense here is very helpful to us. We can see all the APIs that we can pass to, sorry, the parameters that we can pass to our API. All right, so the first thing we can do is pass the self and provide an ID. We'll call it data lake. Data lake. And then I can stop here and we are good to go. With this, I will have my 3 buckets, my 3 medallion buckets, and DSF will create for me my S3 bucket, as well as my CMK KMS encryption keys. Okay, so let's call this data lake, and we can explore what's in it. So well, let's look what's here. We can access our access log bucket. We can get the bronze. We can get the data lake key, which is the KMS key, the gold bucket, and so on and so forth. We're not going to do this now. One interesting parameter that we have, which is the what happens when we want to destroy the resource. So let's say we set up the resource and we accidentally put the removal to destroy, but this is my data lake. If I destroy it, I will lose my data. What we did is we have put some fail-safe mechanism that will automatically switch back the destroy to a retain unless you effectively mean it, and you go back to your CDK JSON. We put it part of the context. We put a context parameter here that says remove data on destroy, and this one is going to be put to true. Usually it is false by default. So this is just a way for us to make sure you don't end up hurting yourself, because once some data is deleted from S3, it's gone forever. Unless you basically
need to, you basically need to be explicit about it.
Yeah. Unless you have versioning or you have some backup. But it's good to have some fail-safe mechanisms in place. All right. For the rest, I'm just going to move ahead, and I will add my data catalog. So my data catalog, it's here. This one is going to be called storage. So with my data catalog, what we have is we will create for you Glue table and databases that maps to the structure of the data lake storage. So you don't need to go and by yourself try to add them and map each table to the location and so on and so forth. So just easy. You get your data lake catalog. Now, the next one, the next thing that I want is, I find it often useful when we do experimentation, is we have some data sitting in some sort of S3 that is not the one we will be experimenting on, but also I don't want to write a shell script that will do the S3 copy, or God forbid, you might end up writing some Spark code to do the copy for yourself. What we do is we have a util class that we call utils. And in this util, we have multiple functions. So we have a data VPC, which is a VPC that comes with the right S3 endpoint gateways. It comes with the NAT gateways already enabled. We have some architecture. This is like if I want an x86 or ARM64, but I have also S3 data copy. And with the S3 data copy, what we can do is I will copy the data from one location to the other. Again, I will just do a very quick copy and paste for here. What I want to also show you through the S3 data copy is you can, if you have, as an enterprise, if you have rules that says, for example, the Lambda that will execute this needs to be in a VPC, you can pass your own VPC. You can also pass your own execution role, which is the Lambda role that will be executing the S3 copy, or you can pass, for example, your security groups. Right? Next is I'm going to create an execution role that can be used by my EMR serverless cluster. And with that, we have a library, we have a utility, a method, a static method in processing. We have many classes here, but it's going to be Spark, EMR, runtime, and then here I will find create execution role. And with the create execution role, this will return for me a role that is able to be assumed straight away by EMR as a principal. I can pass to it my policy, and I can just leave it blank. And that's what I want to do, because I want to use some smart defaults in some smart methods that we have in DSF. And one of them is going to be grant read access to my data lake. So I will do storage, and I will look for gold bucket, and I'm going to look grant read write. Yeah, to my execution role, which is good. Okay. Next is I'm going to create my Spark EMR serverless runtime, and with this, what I will have is a basic or a base EMR serverless application waiting for me. As you can see, we have multiple configuration you can pass, like initial capacity, maximum capacity, network configuration if you want to pass a VPC, and so on and so forth. Now, we've spoken about PySpark application package, and with the PySpark application package, what we can do is we can package our Spark application that is here. We are going to package the wheel of the wheel and the V environment of my Spark application that is hosted here, and I'm going to upload it to an S3 so that I reference it to my Spark runtime. And with that, we have DSF, again, the same processing, and then we look for PySpark application package. I can pass the entry point, my entry path. So where is my entry path here? My entry path is in the SRC, or the source. I have my application name and the asset upload. This will create an S3 bucket for me where I already where I will upload the data, or I can have an artifacts bucket that I control and not DSF. All right, just more copy paste from my side. And I promise we are going to finish this within 100 lines of code. All right. Then I will just add some more stuff. So I want this execution role that I have here. I want to grant it access to the bucket that is created by the Spark application. And that's what I will do here. Spark application, I will access my artifacts bucket. So as I say, or as we said earlier, we always provide you access to the underlying resource. You can even go further and do some escape hatch if you want, but we're not going down that line. Grant read write, so that means my EMR execution role is going to be able to access this artifact bucket. And the last thing that I will add is going to be creating a Spark job. So a Spark job, as we showed earlier, is a step function that will orchestrate the lifecycle of the job on success or on failure, and it will trigger it. Pretty simple here. So what we take is we take the API or the props, the API interface that is exposed by the AWS API, and we expose it to you here. Now, the nice thing here, what we can do is we can do schedule. And with this schedule, I can put a cron job like that says, John Doe will be able to run their application every day at night, or whatever the cron job is going to be defined, or how you would like to define it. We also define the parameters, and these are the parameters that are passed to the Spark Spark configurations. As you can see here, I define my virtual environment for the driver, and the target. Driver environment. So this is not the virtual environment, my bad. This is the environment variable, so that we pass the location of where we read the data and where we store it. As you can see here, I read from the silver, and I write to the gold bucket. And like this, we have created this whole bit here in 15 minutes, give or take. We can make it like, okay, 45 minutes, 1 hour. And now we just empower you to achieve more with AWS as a data platform for you.
And luckily, I have 2 questions for you. One, actually 3. So one was around the S3 copy construct.
Mm-hmm.
Can you talk a little bit about how that works? So when I run a CDK deploy, is that copying data every time I run a CDK deploy? What does that look like?
No, it's once. It's a once deployment. We just take CloudFormation is smart enough to know like the state of the resource, so it will just trigger it once. Behind the scene, there is a custom resource that triggers the Lambda function that does the copy.
Got it.
Yeah, in opposition to the packaging of the application.
Yeah.
Because the packaging, CDK will package every time. So if you change the business code, it will also upload a new artifact in the artifact bucket.
So on the packaging side, there is a bit more really, we try to use all the power that CDK gives us. For example, what we actually happens here is there is a Docker container that will start and that will execute some shell command to package your virtual environment. If you are not happy with our Docker container, you can provide your own definition on that Docker file. So we actually allow you to package your Docker file, part of the Spark application, to tell us how you want to package your application. So, for example, one example would be you have your own libraries and you want to package them in a certain way, or you have some utility files that you want to package, or you want to include some jars like that you load for JDBC, for example. But yeah, this is what we do in PySpark application package. It's really powerful in a way that it accelerates how you can manage the dependencies. You don't have to run a separate process where you do the build and then you upload to an S3 and then figure out that's the wrong S3. So all is managed here within the, let's call it 6-7 lines. And it makes it easy to interact with the resource. What is your second question?
So I just wanted to touch on really quick, when you were going through the processing construct and the various APIs available, we don't have to go too deep into them, but I saw there were a ton of options.
Oh, yeah.
Can you talk a little bit about all the different compute options available?
So the two main ones are going to be EMR serverless as well and EMR on EKS. And what we will do, we will come, for example, if we take EMR on EKS, which is very dear to my heart because I wrote most of it, we will provide you with an EKS cluster that has all the prerequisites to run EMR on EKS, all driven by code, and that follows your life cycle of the application. But what we also do, we will also provide you with some default EC2 capacity in that EKS cluster with Carpenter, so that you just submit your job straight away. Adam, I'm ringing a bell here with containers on the couch. But yeah, that's what we do with the EMR EKS construct. We also provide you more, and this is Vincent will talk about it. In the processing, we also define the packaging, and we define also the starting the job as well as the CI/CD. But again, when it comes to compute, serverless and EMR on EKS with the EKS option, and then we always provide you with some something that gets you ready to start leveraging the service or leveraging the platform that you've just deployed.
Amazing. And I know we probably want to move on here, but
yep.
I just want to say, if you synthesize this code, so we have how many lines of CDK here? It's roughly like 70, 80.
Yeah.
If you were to synthesize that, the amount of cloud formation, and not including the custom resource code and all the really great stuff that's being done, but you're looking at what? Probably over 1,000 lines of cloud formation and custom code there.
Yeah, and if you are using EKS, you will also have 2 substacks, 2 nested stack that are running.
Amazing.
Vincent?
Awesome.
Okay, let's help. We'll continue helping John Doe with his taxi mission.
Thanks, Lotfi. Okay, so the next step, I think you see my screen. Yeah, the next step is to take what Lotfi has built and make it a little bit more industrialized and add some CI/CD on top of this. Because you typically don't want to deploy directly into production. You will have a CI/CD with proper testing, like building the code, running the unit test, then running integration test into a different account or different region, and then validation on production. So yeah, this is what we will do. So here you see we are using the same stack, same components. The first thing I will need to do is to create another stack. Okay, and this is pretty useful because we will use a CDK pipeline to provision the CI/CD. And if you already know CDK pipelines, that's a very powerful abstraction that provides self-mutation CI/CD. So now, not only the data engineer owns the business code and the infrastructure code, but he also owns the CI/CD code and can self-mutate the CI/CD and add, for example, integration test or modify anything he wants in the CI/CD. So I created here, just to be quicker on the demo, I just created a CI/CD pipeline stack here, okay? And I'm using DSF in the processing package. I'm creating what we call a Spark EMR CI/CD pipeline. I give a name to the application. That will be the name of the repository. Behind the scene, it will use code commit, code pipeline, and code build, but it's fully abstracted. Okay. One important thing here is the factory. This is how you pass a stack, an application stack, to be deployed by the CI/CD. And then you also provide some path for the infrastructure code and the path for the application code also. So what is important is the stack factory. So if I go back on the application stack, because it's dynamically resolved. So if you know CDK pipeline, you should know that when you define your CDK pipeline, you hard code the stack class. And this, obviously we can't do that because it's a generic CI/CD pipeline. So we use the factory method. And for this, I will also copy paste some code. That's pretty simple. We provide also a class that you need to implement. So it's an abstract class called application stack factory that you need to implement. And in the implementation, you just implement a method that returns a stack. And the method is called create stack. So this is the method that will be called by the CI/CD to get the class of the application stack and be able to deploy it into the different environments. We pass a parameter that is pretty interesting if you want to customize the behavior of your application stack. So we have a CI/CD stage, which is mostly dev, staging, and prod. And this is how you can also customize. So for example, here I can pass this parameter to my application stack here. And I can also add this parameter into the constructor of the application stack, for example, here. And now I can use my stage to customize my behavior. So if you think about the application stack and the schedule of the step function to trigger the job, you probably have different behavior in staging and in production. In production, you want to cron it, for example, every day or every hour, or you have a specific schedule, but you want to be autonomous, okay? That's different in integration or staging, because here you don't want to trigger it, you just want to trigger it manually to run the integration test. So basically, you will trigger the step function, wait for the results, and get back the result as part of the CI/CD. So that's something you can do with the stage. And yeah, here I will just test what is the stage. If it's a staging, sorry, not for staging, it's a prod. If it's a prod, I will schedule hourly. If it's not, I won't provide any schedule. And then I can just pass my schedule to the job, and it will customize the behavior. That's it. So that's how you customize. And again, it's very powerful in the sense that you can define whatever behavior you want. So that's the first step. So we have this CI/CD pipeline defined here. I already deployed the application. So if you don't know CDK pipeline, you have a bootstrap action that is to initiate the CI/CD with a CDK deploy. And after that, you don't touch CDK anymore. You just commit and push your changes to code commit to propagate all the change through your CI/CD down to the production. So I already did that, and you can see that's the results of my deployment. I have my code pipeline here defined with a code commit source, a build step that will take my, it will build the CDK code, of course, but it will also run the unit test of the Spark application. So if I go back on the code, we strongly recommend to follow, to build your Spark application using classical Python package, okay? It will run the unit test in an EMR image locally. So you won't pay for EMR compute, you just run a PyTest locally in this container as part of the CI/CD during the build step. So it will fail fast. If it's not building and passing the unit test, your CI/CD will stop there. And then you can, again, push some changes. So if the CDK build and the Spark build is okay, you move to self-mutation. And this is where you can change your CI/CD. It will automatically update itself. And then you have a very classical CDK pipeline. So you will publish the assets. That's pretty useful for cross-account, cross-region deployment. You probably have multiple accounts for dev, staging, and prod. It's perfectly handled by CDK pipelines. And then you have the different deployment of the application stack. So here I have two stages, the staging and the production. And I would need to customize this. As I mentioned, the schedule will be defined in the production, but not in staging. So that's how it works. It's pretty straightforward. If we go back on the code, it's 20 line of code. That's pretty cool. one last thing that I want to mention is we also provide a way to run integration tests, and that's very powerful and very needed by our customers. So the idea is first you define an output in your application stack. Here, I want to be able to test my step function execution. I want to be sure that it succeeds. So what I will do is just create a CDK output, a CloudFormation output using the L1 construct. And sorry, it's the Spark job. I will get the step function from the Spark job. I will probably access it. Yeah, state machine and state machine ARN. So I will expose the ARN of the step function with this output, the processing state machine ARN. That's the first step to do. Automatically, the factory will get all the output from your stack and expose it into the CI/CD. So now in the CI/CD, I will be able to reference this output and get the information, the ARN of the step function, so I can trigger it. So what I can do is go back on my CI/CD definition, and there I will add some definition here. So I will point to a script that will run my integration test. Here I'm using a shell script that will just start the step function and wait for completion and render exit 1 or 0 based on the outcome of the step function. This is how I get the ARN of a step function to run. So I will get the output. I will do the link between the output of the application stack and my CI/CD using this variable environment. And obviously, I need also to add some permission to my CI/CD now, because I need to be able to trigger the step machine, the step function. So now I could just commit the code, push it to my repo. With the self-mutation, the CI/CD will automatically adapt and run the integration test.
That's really powerful. That's really powerful, Vincent. Like so you took your application, your entire, data lake, your workflow, your application automation, your application logic, and then you just wrap this pipeline around it. Pipeline self-mutates, and as you said, a lot of what's built into CDK pipelines, that CDK pipelines library is here. That self-mutation, really important when you want to mutate the pipeline, add a new stage, add a wave. That's all here. Once you commit those changes, it's automatically going to update that pipeline. But when you really think about it, your application code, your CI/CD pipelines, your infrastructure as code, generally, these are all fragmented. And I mentioned this earlier, and I'm repeating myself, but being able to take all of that and put that in one place and have the opinion and all of these abstractions built into this is super powerful. And I just want you all to know there are a lot of really great comments that were coming in here. And I just wanted to touch on some. So we'll probably get into this when we talk about the roadmap, but with Apache Airflow. So I'll probably hold off on that. But yeah, just event-driven architectures in general. Is that probably something we'll talk about in the roadmap section?
Yeah, so we need to prioritize. We are not a big team yet. The plan is, if we think big, the plan is to make it more official and supported by the entire AWS organization. We need to prioritize. So we really encourage you to post some and open some GitHub issues to express your need, because we need to prioritize. We have lots to cover. We will talk about the roadmap later. I fully agree with Andrew. This one is very opinionated, but again, with something like 50 or 70 lines of code, you can deploy your full Spark application. Yes, it's a little bit opinionated, but I think it covers a big part of, it's a command pattern. Again, the idea of this library is really to identify command patterns and to make it super simple to reuse.
2 words on this, Vincent. This is a library where it's not like all or nothing. You can pick, what we showed you here is you can just pick 2-3 lines and then plug them into your code. You don't really need to adopt everything if you just are happy with EMR serverless, because it just creates the EMR and provide you with methods that give you good scope down policies. Then all happy for you. Like, you can just stick to this and use it. There is no solid requirement for all of you to use this. You just pick what you need, and it has been built like this. We have spoken a lot about our design principle. One of it is atomicity, meaning that all the constructs that we build need to be standalone. They need to be atomic. So we try not to intertwine them or interleave them. It needs to be standing by itself. And that's one of the most, one of our biggest tenet. The second is this code that you saw here. I have built something similar to it with Vincent, and we were over 2,000 lines of code, and it was breaking a lot because he was making change that I didn't incorporate, and vice versa.
Feedback loop is super slow if you need to push, wait for the code pipeline to trigger, etc. So yeah, that's the point. You have already packaged solution, and you can mix and match. If you don't want to take everything, that's no problem.
Yeah, that's a really good point. Kind of take what you need. You can always, and another great thing is if you're getting started, start with the high level abstraction at that L3. And then if you think you need more, you would just take the components you need and build on top of those lower level components. So just good feedback from the community here. And then let's head over to the roadmap section, but I do want to ask community contributions. Are you accepting, I assume, community can contribute, and we have a process for that as well?
Yeah, we already have some contributions from partners, opening issues, also some customers expressing some needs related, for example, to Glue. That's something we are thinking about. But again, we need to prioritize. We will talk about the roadmap. I think the long-term vision is pretty clear. We will let Jenan explain it.
Perfect. All right, so I have the repo here. But yeah, let's get right into the roadmap.
Exactly. So let me quickly share my screen again. I hope you can see. So you're a little bit running out of time, so we're going to keep this very simple. So our roadmap is publicly available as well on GitHub. So please go ahead and check our GitHub. There's also, I think, a decent website that you can check out and explore all the different constructs that we have, including different examples. So really go deep dive. So when it comes for what's ahead, what we're working on currently on, so we'll keep integrating different AWS services. So for example, right now we're working on QuickSight. It should be coming very soon, as well as support for lake formation, MSK Connect. I've seen in chat somebody mentioned, are we going to integrate with managed Airflow? Yes, that's definitely on the roadmap. That will be a very important part of the orchestration layer. But we'll also keep working on the high-level abstraction. So you can imagine in DSF that we'll have something like incremental materialized views, but also streaming support for data zones, so for the governance layer. It's not here, but we'll also be working on DBT. We know many customers out there are using DBT, so that stands for Data Build Tool for different transformations that you want to do. That's something we're going to be integrating as well in the future. And we'll be working to simplify the actual usage. So we're thinking about additional abstractions on top of DSF, just to simplify how you interact with the framework for some really common use cases. But for example, with Amazon Data Zone, we're working on custom blueprints. So that would simplify the integration of different solutions that you build with DSF, with the Data Zone that will be, that is actually a governance layer. So what we invite you to do is to build with DSF. Go ahead and experiment. It's available there on GitHub. We announced it recently. We'll share a blog post in the chat as well that you can read. So go ahead, experiment, build. Also reach out to us. You can find us on LinkedIn. You can also open issues on GitHub. So please reach out, share feedback with us. But also you can contribute. It's open source. It's on GitHub. all contributions are welcome. So if you'd like to contribute, please do so. And then finally, sharing our website and GitHub. I think you already put it in chat. Thanks. So please go ahead and check it out.
Amazing. Okay. So I think that's a wrap. Just to recap, again, we've posted the website, the blog. Check it out, play around with it, get familiar. As you can see, Andrew already in chat has been deploying it. Really good feedback so far. So
Awesome.
issues, feature requests, check out that GitHub repo, submit those there. Janan Lofty, Vincent, great presentation. As you can see, a lot of really great feedback here. Looking forward to seeing this project, these constructs just continue to grow and iterate and do some really great things. So we'll wrap it there. Again, if anyone has any questions, please feel free to reach out. You can check out the CDK channel, CDK Live. Just cdk.live is the website. Feel free to subscribe. We'll always have content coming up every few weeks here. And we also have previous shows, previous tutorials, things you can check out as well. So we'll call it there. Thank you guys for showing up. Thank you for everybody here that was asking questions, chatting. It was a really great experience. So we look forward to seeing you next time. So thanks, guys.
Thank you all.
Thank you, Adam.
Thank you, Adam.
Thank you all.